A fish tank has a rectangular base with a width of 2, a length of 4, and then rectangular sides that have a height of 3. So it's just a cube. If the tank is filled with water and water weighs 62.4 pounds per cubic foot, find the work required to pump all the water over the top of the tank. So let's draw a picture of this tank. Okay, something like that. The base is width of 2 feet, length of 4 feet, and then the sides have a height of 3 feet. Okay, so there's my fish tank. The tank is filled with water, and we want to pump all the water out over the top. So what makes this a hard problem is that some water takes more work to pump out than others. So water near the top takes less work to pump out than water near the bottom because it doesn't need to move as far. So I'm going to divide the water into teeny slabs of a very small thickness that all have to move approximately the same distance. So I'm going to do a slab sort of somewhere in the middle-ish, just to represent a generic slab of water. So this is just some rectangular slab of water that needs to get pumped out of the fish tank. So we're going to have it be at a height of x, and its width is delta x. So the work we have to perform on that slab of water is force times distance. The force is how much that water weighs, right? How many pounds does that slice of water weigh? So I need to know its volume in cubic feet and then multiply that by 62.4 pounds per cubic foot. So force is going to be 62.4 pounds per cubic feet times the volume, the number of cubic feet. So the volume of that slab is going to be 4 times 2 times delta x. Okay, so that's force. And then distance is how far that slab needs to travel, which is x feet. Right, so this is going to be 0. Have that be 0 and this be 3. So it has to travel. No, switch those. This water has to travel 0 feet to get out, the water at the top, and the water at the bottom has to travel 3 feet to get out of the tank. So the water at this slab has to travel x feet to get out of the tank. So my distance is x. So that's the work done on a single slab. When you multiply that out, you get 1,497.6. Okay. So this is 1,497.6 x delta x. That's the work done on a single slab. Then I have to add up all of these slabs at all these different x values. So that would be x1, x2, x7, xi, right? So I have to add up all these slabs. So I'm going to take a sum for each xi. So 1,497.6 xi delta x. I goes from 1 to n, and I take a limit as n goes to infinity. This is my total work done. And that's a Riemann sum that translates to an integral. So this would be 1,497.6 x dx. And my x's are ranging from 0 to 3. My heights that I have to pump this water out. So I just calculate this integral. It becomes 748.8x squared, evaluated from 0 to 3, and you get 6739.2, and the units on this work should be foot-pounds.